Welcome back and thanks for watching our lessons. This is lesson 29, pure mathematics. We want to make arithmetic progressions simpler. We want to make arithmetic progressions simpler. Previously, lesson 28, we discussed how they come about, where we said that if A is the first term, I've said A is the first term, and D is the common difference, the one I called that constant value that is being added constantly. We can generate a series from there. That is, the first term being A, the second term is going to be A plus D, the next one will be A plus D, the previous term, then plus the constant term D, which we have called the common difference. The next term is going to be A plus D, then plus D, and so on. So, I can have A plus D plus A plus 2D plus A plus 3D, and so on, and so on. So, when you look at this, from the first term, we've added a D. Then from the previous term, which is A plus D, we've added a constant value D. So the D, which I've called it the common difference, is the one that you keep adding. Such a series is the one that gives us what we call the arithmetic progression. And I've said this is the first term, this is the second term, this is the third term, this one here is the fourth term, and so on, and so on. Now, the more general way of expressing APs is given below. We have A plus D plus A plus 2D plus A plus 3D plus and A plus n minus 1 into D. A plus n minus 1 into D. You can even add on, and so on. I've talked of the more general way. What I was trying to do here, I was trying to generate terms which represent arithmetic progressions. I was trying to generate terms that give us arithmetic progressions. But we have to look at a more general way. And in this expression, or in this series that I've given you, I've included the nth term where A is the first term, D, I've called it the common difference, and UN, which is A plus n minus 1 into D, which is the nth term stroke last term. What am I trying to talk about here? When I was talking about sequences, I said the expression for the nth term is very important. The expression for the nth term is very what? Important. Now, here comes my series. This series is arithmetic in nature, or it follows the arithmetic progression. I cannot fully complete it without giving its nth term. And I'm emphasizing it can be the nth term, or somewhere, somehow, it can be the last term. When is it the last term? If you're given a series which is finite. In other words, a series which has got an end. Such a series which has got a last term, its nth term then applies. Its nth term then applies at that level. Then it applies at that level. It applies at that level. NB. The common difference can be a positive, comma, a negative, comma, a decimal point, a fraction, or any integer. I've said it can be an integer, a fraction, a positive number, a negative number, or that kind of arrangement. All that can talk of the common difference. Don't forget, I've talked of the first term, I've talked of the common difference, and I've talked of the nth term of this series. And how do we get D? Now, if you're given a series, for instance, 1, how do we get D? How do we get D? Consider the series below. We have 1 plus 3 plus 5 plus 7 plus 9 plus 11 and so on. If you need D from here, remember A is 1 and I've said that is the first term. Then I've said D is the constant value, the one that you keep adding on the previous term to get the next term. No, it is the common difference. It is the common difference. So, how about if you find a series like that one and you're interested in getting D? That D can be got by getting 3, then you take off 1. Or it can be 5 minus 3. Or it can be 7 minus 5. Or it can be 9 minus 7. Or it can be 11 minus 9. As you've seen, we kept adding the D on the previous term to get the next term. don't get the first term and the third one. No. It is terms that are flowing or that are near each other. Don't pick 9 minus 5 because you're interested in getting D. It is the subsequent term or the next term minus the previous one. As you see, 3 minus 1 will give you 2. 5 minus 3 will give you 2. 7 minus 5 will give you 2. 9 minus 7 will give you 2. I'm using terms that are flowing, so that are following each other. Don't pick on each and every term if you're interested in getting a D. If you're interested in getting a D. Examples. Examples. In the series below, find the first term, the common difference, and the number of terms of each series. So we have Roman 1. Roman 1, we have 2 plus 4 plus 6 plus, it is going up to 46. That is a plus sign. Roman 2, we have 6 1/4 plus 7 1/2 plus up to 31 1/4. Up to 31 1/4. Now, solution. Roman 1, we have 2 plus 4 plus 6 plus up to plus 46. The question wants you to get the first term. The first term, I've called it A, and the first term is 2. That is the first number that appears in the series, and it is a 2. The common difference, D, is if we get the subsequent term and take off, I've used 4 minus 2. The subsequent term of after 2 is 4. That's why I'm using 4 minus 2. You will get the same result if you use 6 minus 4, and even D is 2. Then the same question is asking for the number of terms of each series. Now, number of terms from UN, which is A plus N minus 1 into D. The N stands for the number of terms. Okay? That N stands for the number of what? It stands for the number of terms. Now, if that is the case, there is somewhere where I said this one acts as the nth term, and it can also act as the last term if at all you're given a finite series. In other words, if at all you're given a series which has got an end. When you look at that series in the Roman 1, it is it is an arithmetic series or an arithmetic progression, because to generate the next term after the other, you keep adding a 2. So we are interested in the number of terms from 2 up to 46. For us to get those number of terms, we have un, which is a plus n minus 1 into d. Our un is the last term and it is 46. Our a is the first term, that is 2, plus n minus 1 into 2, that is our common difference. So you can see that I can start by taking the 2 this side. We have 46 minus 2 is equal to 2 into n minus 1. So 46 minus 2 gives you 44. 44 is equal to 2 into n minus 1. Divide by 2, divide by 2. This one will give you 22 is equal to n minus 1. You're interested in n, so it will be n minus 1 plus 1 is equal to 22 plus 1. So that one cancel with that. You have your n as 23. Meaning from 2 to 46, you'll have 23 terms. If someone starts listing them down without skipping any, and then that person counts manually, starting with the 2, you'll end up with 23 what? Terms. The purpose of this is to help you simplify some of these questions without labeling, as you can see what I've just done. Trying out Roman 2. Roman 2 we do have 6 and a half, that is 6 and a quarter, plus 7 and a half, up to 31 and a quarter, plus 31 and a quarter. A is the first term and it is 6 and a quarter. D, which is the common difference, we say that one is given by 7 and a half, then minus 6 and a quarter. These are fractions, so you can put it as 7 and a half, that is 15 over 2, then minus 6 times 4 will give you 20. 6 times 4 will get 24 plus 1, 25 over 4. So the LCM is 4. 2 goes in 4, 2 times 15, that one will give you 30. 30 minus 25, 4 goes in 4 once, times 25 you will get 25. So this is 5 by 4. That is our common what? Our common difference. Now, after coming up with that, the question wants you to determine the number of terms. That is, if you list them down and count them from 6 and a quarter up to 31 and a quarter, what do you get? So if I use un is equal to a plus n minus 1 into d, I've said the expression for the last term, if at all you're given a finite series like the one we have there. So we have our last term as 31¼ is equal to 6¼ plus n minus 1 into 5/4. You can place this in, you can put it as an improper. You have 31 times 4 giving you 124 plus 1, that one will give you 125/4. This is 125/4 is equal to, this is 25/4 plus n minus 1 into 5/4. So if I bring this one this side, this is 125/4 minus 25/4. That one is equal to 5/4 into n minus what? Minus 1. So you have 125 minus 25 giving you 100. So this is 100/4 is equal to 5/4 into n minus 1. So from there you can calculate, shall pick it up from there.